So a quick question. So are you guys seeing the screen with the presenter notes or without the presenter notes?
Without the notes.
Sorry?
Without the notes. I can just
Without the
see.
notes. Okay, yeah. Yeah, just to make sure that you can see the entire screen.
Gautam, do you want to try kind of changing your slides? At times it doesn't work when people are presenting. So if you go to your next slide, will we see it or not?
Can you?
Yeah. Okay, great. It works.
Okay. Yeah, this is the first time I'm actually doing a full-fledged talk on Zoom. So I just want to do a trailer. Okay, I guess we can begin.
Sure.
Okay, so good evening, everyone, and good morning to our friends who are joining from the other side of the world. I'm Gautam Kaki, an assistant professor of computer science at CU Boulder. So welcome to this information session on programming languages and verification group at CU Boulder. So just a quick heads up. So we are recording this meeting. So that's I want to put it out there. So I'll begin this session with a short presentation introducing CUPLV and our work, and then open up for questions, right? So first of all, let me say that it's unfortunate that we couldn't get you over to campus this year and do this session in person. Otherwise, you could have really enjoyed the stunning and gorgeous views around the university. So for example, the background image on the slide is of the beautiful Flatiron Mountains as seen from the Chautauqua Park. So both of these, Flatiron Mountains and Chautauqua Park, are just a stone's throw away from the engineering building where we have our computer science department. So in fact, the logo of PLV, which you see at the top corner of the screen, is inspired by this view. So the three peaks actually represent the three Flatiron Mountains. Right? Okay, so with that, let me begin. So, okay, first of all, so who are we, right? So at a fundamental level, we are a collection of like-minded faculty and students who are really interested in programming languages, formal methods, verification, and their applications in various subdomains of computer science, such as distributed computing, artificial intelligence, concurrent programming, etc., right? So we are currently 9 faculty members with expertise in diverse fields. I'm going to talk about that a little more in a few months. And we also, of course, have many masters and PhD students. I only managed to get pictures of a few of them, which I've included on the slide, right? Okay, so what do we do, right? So a defining characteristic of programming languages and verification research at CU is its breadth, right? So besides pushing the envelope on programming languages, formal methods, and verification, which is the core of our work, we also work on interesting applications in various subdomains of computer science, such as autonomous systems, data-intensive computation, software engineering, and human-centered computing. Right? So these are sort of our broad themes that characterize the research that's done at CUPLV. Right? I'm going to give a sneak peek the kind of projects that we undertake in each case, so that you'll get an idea of the sort of things that are happening, the exciting things that are happening at CUPLV. Right. Okay, so firstly, our research into foundations of autonomous systems is led by professors Sriram Shankar Narayanan, Fabio Somenzi, Asutosh Trivedi, and Mazid Jamani. Right. So they and their students collaborate on a lot of interesting projects, a few of which I've listed on the slide. Right. So the first one, a very interesting project, I'm going to talk about it in detail in a few minutes, is modeling and verification of artificial pancreas system. Right. Another interesting project is by Mazid Jamani and his students, where they, in the TAKAS paper, they essentially show that it's possible to synthesize a provably correct controller for BMW i320 self-driving car using a set of tools and techniques that they developed in the lab. Right? So we also do work at the foundations of reinforcement learning because of our background in formal methods. In particular, Fabio and Asutosh have worked on bridging the formal requirements on controllers. For example, that a car shall not go beyond a lane, such kind of formal requirements, and the scalar reverse which are required to do reinforcement learning. Right. So they bridge these two worlds using the insights that they've gained from formal methods. So Fabio also has this interesting project on formal on formal methods to essentially derive a controller for continuous space Markov decision processes from first principles, which is a very exciting project if you're working at the foundations of reinforcement learning. So yeah, these I've just given a quick overview of the sort of projects that we do under autonomous systems, under the broad field of autonomous systems. Hopefully, they would have given you a little idea. I'll also go on to the other themes as well. And as I mentioned, I'm going to expand on a couple of these projects later, right? Okay, so next, so our next research thrust is on applying programming languages and verification techniques to reason about complex systems, right? Complex real-world systems, computer systems. So here, Professor Dirk Grunwald and I work broadly on applying these techniques to real-world computer systems. So recent focus area that Dirk and I have been working on is designing new language-level abstractions for data-intensive computations, which have become really prominent of late because of the proliferation of big data and machine learning. Right? So we strive to, we work on the projects that give programming language level support to programmers to efficiently build these sort of applications, right? So for instance, Dirk and his students have developed a language called the SAL, which is a short for Streaming Analytics Language, that helps programmers build very efficient and complex analytics on streaming data, the data that is streaming at a really, really high volume and rate. Another interesting project, which was done in my group, is which title Mergeable Replicated Data Types, MRDTs, which are a sort of a new kind of distributed data structures that were inspired by Git, the Git version control system. We basically come up with a programming model around these data structures, which makes it possible to build coordination-free, highly decentralized distributed programs. For example, blockchain, for example, is being the straightforward example. Another interesting project that we did in our group is Quillia. It's a system called Quillia that makes it possible to write functional programs such as the ones that you write in Haskell or OCaml over with strong safety guarantees over eventually consistent NoSQL stores such as MongoDB or Cassandra and such, right? So the system, is actually, we have run it and found, besides giving strong safety guarantees, is also found to be really competitive with respect to the real NoSQL data stores that are out there. I'm happy to talk about this later if you're interested. Okay, so moving on, our next area of focus is software engineering and verification, which is led by Professors Evan Chang, Danny Digg, Sriram Shankaranarayanan, and myself. So one of the exciting projects in this area is done by Evan Chang and his students. It basically deals with mining API usage graphs from open source Android applications to basically identify unsaid best practices and anti-patterns, right? So there are a lot of open source applications. So how do you make use of, how do you mine the code of these applications to identify the patterns, that are, that may turn out to be either the best practices or anti-patterns, right? So that's one exciting project. Another interesting project which Evan and his students have done in collaboration with Uber is the use of this really sophisticated type system called refinement types to basically ensure safety of Uber Eats and Uber driver applications, right? So basically, at the fundamental level, is the use of type systems or the formal methods to ensure that your Uber app doesn't crash as often as it does. So next is a project by Danny Digg and his students, which is published in UPSLA 17, right? So in this paper, so Danny and his students will basically do a large-scale study of how people are using Lambda expressions in Java. And based on the study, they have actually proposed concrete recommendations to improve both the language level program performance and the developer productivity for Java developers, right? So that's a very influential project. It has actually won a Distinguished Artifact Award that year at UPSLA. So yeah, that was by Danny Digg and his students. Another exciting area of research that falls into the broad category of software engineering and verification is by Sriram and his students on probabilistic programming, right? So in their static analysis symposium paper in 2014, Sriram and his student Alex has shown that for expectation invariance on probabilistic programs, you can compute them efficiently using fixed point analysis, which is very unintuitive sort of a thing, which is a very clever observation. And for this, they've actually won Best Paper Award at SAS 2014. And lastly, is my project on automated verification of weakly isolated database transactions, such as non-serializable transactions you find on, let's say, MySQL or Postgres, etc. Right? So it turns out that those are, although in your undergrad classes you would have learned that these transactions are serializable, etc. But in practice, none of the transactions are really serializable, which means there are a lot of, which results in a lot of bugs in real programs. So we developed a sort of formal methods and automated techniques to automatically detect those bugs and find and fix those programs. So this was published in POP 2018. Okay, so that's about software engineering and verification. Now let's move on to our last theme, which is human-centered computing. So Professor Ben Shapiro is the one who actually actively works in this area. So he has joint appointments in both the College of Education and in CS. So one of the interesting projects that he has done is the study of ethics for design-based research in online social networks, which has become a hot area of debate of late, right? His work also spans such diverse areas as distributed cognition theory to analyze how effective the collaborative learning environments are in computer science, in teaching computer science, right? So that's one. Another, Ben is also known for inventing this language called Blocky-Talkie, which is a visual programming language where you can play around with blocks, etc., to learn programming networked physical devices such as Raspberry Pi, etc. Right. So this is quite useful to actually teach the high school kids to the programming with an array of physical devices, embedded devices, etc. It's quite fun to program in Blocky-Talkie. So yeah, these are broadly the projects under human-centered computing. So I've only touched upon the high-level overview of various projects. Now, as I promised, I'm going to spend some time doing a deep dive on a couple of projects. So far, any questions? Okay, if there are no questions, then I'll move forward. Okay, I'll spend some time on the artificial pancreas project, right? So this is a very, very exciting project, which actually is quite impactful in real world. So artificial pancreas project is led by Sriram and his students, Taisa Kushner, Sauradeep Datta, Shinchan, and Sergio Moore. First, a little bit of background for those of you, with high school, just to recall high school biology. Humans have a gland called pancreas that regulates the blood glucose levels, right? Using a hormone called insulin. So in type 1 diabetes, so beta cells, which are islet cells of pancreas, are damaged, which means they cannot regulate insulin to basically regulate the glucose present in the body. So they cannot convert the glucose into energy, resulting in starvation and cell death, right? So consequently, blood glucose levels may fluctuate widely beyond the acceptable levels, sometimes falling below the minimum level of 70 milligrams per deciliter, a condition which is called hypoglycemia, which might result in losing consciousness and eventual death. And the other end of spectrum, the glucose levels might go above the acceptable threshold of 180 milligrams per deciliter, which is a condition called hyperglycemia, which is, although not as dangerous as hypoglycemia in the short term, it does result in long-term damage to heart and kidneys and so on, right? So that's the that's the overview of what pancreas does and what the role of insulin in the body, and what happens when you have when a patient has type 1 diabetes, right? So for the patients with type 1 diabetes, the treatment involves basically injecting artificial insulin through external infusion, right? So traditionally, patients themselves are responsible for injecting insulin at appropriate times, but this is prone with dangers because, first of all, patients are not experts. Second of all, patients are not always vigilant, so they might forget when the insulin has to be injected, or they might inject more levels than what is needed, etc. Right? So the ambitious goal of Artificial Pancreas project is to automate this process of insulin infusion through by means of a subcutaneous insulin infusion controller, right? So it's an artificial controller called insulin infusion controller that lies below your skin and basically does automated job of pumping in insulin into the body. Okay, so that's the aim of Artificial Pancreas project. So the controller receives constant measurements of blood glucose levels from a continuous glucose monitor, a CGM, so which has basically a lots of sensors, right? So it senses the blood glucose levels are tiny and sends the data back to the controller. And when blood glucose levels are low, the controller opens the pump and lets the insulin in. And conversely, when the glucose levels are high, you actually, the controller has to turn the pump off and let the, sorry, I did the other way around. So if the glucose levels are high, then you turn the pump up so that you process the insulin. If the glucose levels are low, you basically turn off the pump so that you don't need any more insulin going into the body, right? So that's the job of insulin controller, right? So simple enough, right? Unfortunately, in practice, this is not as simple as it sounds, because firstly, real-world sensors are not perfect. So there is sensor noise and sensor delays, which could affect the measurement of blood glucose level, right? So it's your sensors are not always perfect. But secondly, and more importantly, the dynamics of insulin metabolism in a patient body is not simple at all. It is in fact very, very complex. It is governed by nonlinear ordinary differential equations. So the model that best explains how insulin flows through the body and processes glucose is a nonlinear model with ordinary differential equations. And it depends on more than 30 parameters that vary from patient to patient, right? So if someone develops a controller for an artificial pancreas system, there's always a question of, is it safe and will it work, right? So this is a pressing question that actually is crucial to the practical adoption of artificial insulin controllers, so artificial pancreas systems, right? So in CUPLV, Sriram and his students have made sort of impressive advances in solving this problem. In particular, they've introduced this several new verification and model checking and data-driven synthesis tools, techniques for nonlinear control systems to basically predict the behavior of nonlinear control systems, of which artificial pancreas is just an example, right? So for instance, in their most recent paper published in the Journal of Computational Methods and Systems Biology, they show that it's possible to predict the bounds on blood glucose levels with probably low error rate. The key is the probability. With probably low error rate by combining predictions from multiple neural networks with a conventional technique called mixed integer optimization, right? In another paper that they published recently in EMSoft, which was nominated for the Best Paper Award. So Shinchan, Sergio, and Sriram introduced a new concept called compositional relational abstraction. So to reason about this nonlinear hybrid cyber-physical systems. So this is a classic application, demonstration of how the techniques that we have in the programming languages and formal methods that we have been using to reason about the normal everyday programs can also be used to reason about really complex cyber-physical systems to make a dent in the practice. Right? And we are doing it in CUPLV lab. So this has been influential research. So Taisa Kushner, who finished her PhD this year with her thesis on this project, has actually won a CRA Computing Innovation Fellowship for this year for 2020. Right? So this is quite an impactful project in practice. Okay, now let's switch gears a bit. Okay, so this is about the artificial pancreas project, but if you have any questions so far, please feel free to ask. Nothing? Okay, so let's move on then. So now I'm going to switch gears a bit and talk about application of programming languages and verification in basically reasoning about complex real-world systems, right? I'm sorry. 1 second, my slides are not behaving. Okay. Yeah, so specifically, I'm going to talk about the project on our project in our lab on mergeable replicated data types. So let me give you a bit of background. So most of you would have used applications such as Facebook, Twitter, etc., which are essentially geo-distributed, right? So they're available throughout the world, and they're always on. So modern applications such as Facebook, so they replicate their state on multiple geographically distributed servers connected via public internet. So this is called geo-replication, and it is done for multiple reasons. So firstly, resilience against failure, so that if one data center goes down, you still have the data and you still are able to serve your clients. And second, for trust decentralization. And third, a most important reason is essentially to reduce latency and meet the availability needs of the users, right? So basically, the core idea is to run the service as close as to the user as possible, so that you can enable low latency access to the service and increase the availability of the service. Because even if there are network partitions, users can reach at least one of the replica for the service. So that's the idea for the geo-replication, or replicating the data across various data centers in the world, right? Okay, so but this data is not always unstructured data. In particular, it could be the actual normal program data, which you're used to storing in various kinds of data structures in memory, right? Just as centralized applications organize data in terms of data structures, a decentralized geo-replicated application also can expect to do the same. However, the management of or the behavior of these data structures need not necessarily be same as what you expect in a sequential setting when you have no multiple servers, etc. Right? In particular, one change that the user does on one replica or one data center, and the other change that another user does on a different replica may not go well with each other, may conflict with each other, and in which case you actually end up in an inconsistent state, right? So there are various examples of this form, and there are various bugs that came up in real systems, such as in e-commerce applications, etc. Because of these sort of issues, there's in fact a study by Bailey's et al. In 2016, I think, basically describing these sort of bugs. But the key idea is that it's not simple to engineer data structures that work perfectly on all in this replicated setting, right? So how do you build these sort of data structures from sequential data structures? So that's a problem we address in this work. So our core insight actually comes from something which we are all used to, which is GitHub. In GitHub, we know, there is a distributed development. You can fork off a particular version to various branches, bug fix, and feature. And if you know how to merge these different changes in a comprehensive way, so essentially you are like you have a consistent state, right? So you have both the changes and you have a consistent version. So this is essentially the idea behind Git. That's how we do distributed development in Git. So the idea is, how about we adopt the same kind of workflow for data structures, right, in real time. So you have data structures sitting on multiple replicas or multiple machines. So they're each basically having changes of its own. So if you know how to merge these two data structures in a way that retains both the changes on both the ends, then it's actually, you actually have a consistent version that does not lose the rights, right? So that's the core idea. So in our work, we have demonstrated that is in fact this sort of thing, whatever, the merge, we call this as a mergeable replicated data structures. So basically designing mergeable replicated data structures from sequential data structures is something that can be done really easily, and that's the contribution of our work. We have shown that by basically making deductions from first principles, you can actually methodically derive these mergeable replicated data types from your sequential ordinary data structures, right? So this is version control model of replication, which is inspired by version control systems, just Git. Okay, so as I mentioned, the key insight here is data type plus merge function is mergeable data type, and mergeable data type plus version control model of replication are mergeable replicate data types. So we have a system called Quad. So the details are not important, but we have a system called Quad that implemented it. And we wrote a lot of interesting applications using in this model, including a clone of Twitter, a collaborative freehand drawing application, etc. So this turned out to be quite an impactful project, because it actually improved the developer productivity a lot. Like, as in you can now spin up decentralized application in a matter of few minutes by writing a small amount of code, because a lot of the process has been automated using the mergeable replicated types. So this particular research was covered in famous popular blogs and also on the Hacker News. So if you want to take a look, you can. It's available on Hacker News, right? So yeah, so that finishes our deep dive into MRDTs. So artificial pancreas and MRDTs are examples of the sort of two impactful projects that we at CUPLV undertook. So we have more such impactful research has come out of CUPLV in the last few years that was published in top venues. So here is a list of recent papers or that we have, that were published in venues such as NeurIPS, UPSLA, ECUP, ICFP, etc. Right. So in each of these cases, so I've listed various papers. So the recent one by and Shankaranarayanan in NeurIPS. So each of these, so I've highlighted, basically the students that are involved in red, and CUPLV professors in blue, right? So as you can see, so we basically have a lot of very impactful work done in collaboration with students that's published in a top, really good, impactful venues, right? And of course, these are all happen in exotic locations, so we get to travel to these with our students as well. So that's a fun part. So another interesting aspect or a distinguishing aspect of PLV research at CU is that it has collaborations all over the world. It's highly collaborative, right? So as I mentioned, one of the projects that Evention has undertook in collaboration with Uber. So there are more such projects, a lot of them in fact, with MSR in Cambridge, in Redmond, in India, and in Beijing. We have collaborators in IST Austria, Tongji University, China, NEC Labs in New Jersey, etc. Right. So the advantage of having this sort of collaborations is, of course, we get our students get a lot of exposure working with different people with a different approach of solving things. But also concretely, we get, collaborations essentially means more opportunities for internships and eventual jobs for our students, right? So this is, so this sort of slide shows the breadth of our collaborations, right? And yeah, as I've alluded to a few of the PLV alumni before, for example, Tessa Kushner, but our alumni are, there are quite a few of our alumni who have done really, great in their career, right? So Tessa, as I mentioned, has recently won Computing Innovation Fellow, and she's doing some really, really good work at Oregon Health and Science University. Alex graduated in 2017, so he won Raja Kuso Young Researcher Best Paper, and also a couple of other best papers as well. And is now is working. He's working in a startup, basically as a senior research scientist here at Boulder. Sam Blackshear is who earned his PhD in 2015. Is a Facebook PhD fellow in 2014. He joined as a research scientist in Facebook immediately after, and he's now working for Novi, which is a spin-off that works on blockchains for Facebook, right? There are a lot of others which I couldn't cover on this slide. A few of them, for example, Saeed recently graduated. He took a professorship at UT El Paso. Jedida, who did some really good work in network program synthesis. So he is now an assistant professor at Colorado School of Mines. Todd Mitkowitz, who's graduated a long time ago, is now a principal researcher at Microsoft Research Redmond. And Devin Coughlin, who also graduated in 2010, is now leading the security tools and program analysis group at Apple, right? So they are sort of partly responsible for driving LLVM, right? So this slide should have given you an overview of like how our alumni are doing, right? And of course, our bachelor's students have done, and also our master students have done internships at a lot of prominent locations such as Google, Facebook, Toyota, Microsoft Research, Uber, etc. Right? And not only all the work, we also have a lot of fun. So PLV group hangs out together. So we usually have group meetings. So in normal times, now that it's pandemic, we can't do this. But we usually have meetings more than twice a semester at the famous Dushnabet tea house at Boulder. We travel to conferences together quite often, given the rate at which we are, we send out papers. And of course, we also we have a very collaborative environment. We basically teach each other and build things together. We are basically invested in each other's growth and success. So yeah, maybe hopefully I get to see some of you along with this next year. And for more information, you could go on to our website, plv.colorado.edu, or email. So under the people tab, there are, all our contacts are listed. You can email any of us for more information, or if you want to talk in depth of any of the with respect to any of the projects that I mentioned. So yeah, I think that's all I have today as a structured presentation. But of course, I'm more than happy to discuss any questions or any thing that you guys want to discuss. Right.
Hey, Gotham.
Hi, Spencer.
I was wondering, sort of, what was your background that led you into this field of research and your current position as an assistant professor?
Background during my PhD or background before my PhD? Like, at what level do you expect me to answer?
I guess going into your PhD and.
So going into PhD, so actually, yeah. So I'll probably try to answer. Since we have enough time, we can answer both the perspectives. So going into PhD, so I was previously working at Yahoo in India, and so we are, I was basically experimenting, writing a lot of asynchronous code, and I was really interested in how asynchrony works, how closures work, and everything. And I could see connection to this to the map reduce work, which other group at Yahoo were working on. So if you know, map and reduce are just primitives from functional languages, and so are closures and this asynchronous callbacks that you find in JavaScript, right? So there is a structure, a unified structure in all of this, and I got really interested in it. So eventually, that sort of formed my intellectual, basis to pursue my PhD in programming languages and applications and distributed systems, right? So that's what I had going into my PhD. But mind you that I actually don't have, any significant recent experience going into PhD. I'm very curious. I was very curious. So that's the only qualifications, so to speak, that I had that I was going into PhD, right? So coming out of PhD, of course, during my PhD, I've done a lot of work at the intersection of PL and distributed systems, and that's what is my led to my appointment here, and that defines my current work at CUPLV. Did it answer your question?
Yes, very helpful. It's nice to hear more of that you came in with a very open mind, not really sure what you're going to do with it, and then into something.
Definitely, there is nothing wrong.
Right.
Yes, no, absolutely. We do not expect all our students to come with fully determined with a very clear plan on what they want to do in their PhD, right? It's okay to just have curiosity and not be very clear about what you want to do. We can help you figure that out. As a first 1 year or so, you can work with various posts. Fortunately, we have very collaborative environment here. So even if, let's say, I offer you admission, you can still work with Evan or Sriram and figure out what interests you most, and then decide your thesis work.
Thank you.
Okay.
Does the CS department have like a rotation program for like first year PhDs?
Hi. I can't find your name here. What's your name? Sorry.
Nikhil.
Nikhil. Hi, Nikhil. Yeah, so we don't have a formal rotation policy, like as in there's no thing as you go from one lab to the other doing various things. But if you choose, I can't speak for other research groups, but if you choose to do work in CUPLV, you can actually, rotate, do work, any sort of collaborative work with any of the professors that I mentioned at the beginning. But if you want to explore the other areas beyond PLV, then you can do that as well. But you'll have to speak with the corresponding professor in that area, right?
Okay, yeah, makes sense. Thanks.
Hello, Professor. Namrata here. I had a doubt regarding the MTDR databases that you just mentioned. So
MRDTs, sorry.
Yeah. So MRDTs. So in situations like a failover, so wherein one database crashes or some situation like that, so is there a mechanism wherein we pick up from one version and build the database, or should we take from the initial version. So like how is that mechanism planned in such scenarios in terms of failover?
Yeah, that's a good question. So let me answer that question with a question, right? So what would you do in case of Git? So let's say you have a version, you and your friend have forked out a version, right, to work on, and suddenly your friend has gone offline, right? He is nowhere to be found, and you're working on your version. So eventually you submit your changes to Git, right?
Yeah.
But after a while, your friend who has failed over, that is, who went offline, can now come online and now push his changes. Now, provided that you can always merge your changes, or like all the changes are mergeable, so that's the basis for mergeable types. You can now have the whatever changes that your friend has done concurrently while he is being offline, right? So in that sense, you need not start from original version. You can pick up from where you have left and essentially continue the computation, right?
Yeah. So the thing is, so I might not want the version that is already there. Like in Git, like I want to cherry pick from a particular version. So I don't want the previous version in my new repository, something like that. So in that case, I mean, are there, so for example, a branch, for example, there is something else in that branch. So I want my new database failover version to pick up from another branch. So is there, mechanisms for that way in kind of databases? For example, in kind of databases,
Yes.
another branch might have another column or something in the database. So
yes.
I mean, for example, if I want to merge in future, there'll become a merge conflict, right?
Yeah, you'll get a merge conflict if you don't know, if there are cases where two changes are not mergeable, right? But so MRDTs are structured in a way that statically they ensure that all the changes are mergeable. That is, if your program compiles, then it is guaranteed that all changes are mergeable, which means that forever, any of the changes that were ever done in any branch are mergeable. So that's one point. But coming back to your question of, I want to cherry pick a particular version, I don't want latest version. Yes, of course, that would be possible. So for that, so that's not part of the data type itself, but that would be part of the distributed computing model, the actual programming model that you're going to use. Let me point to a work that, in fact, our colleagues at IIT Madras have done recently. So they published a paper in A+, which extends our work, and they've actually proposed a programming model called Banyan, which actually is built on top of MRDTs and does precisely what you say has to be done.
Okay, thank you.
Hello.
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 Hello. Is it Satish?
Yes.
Hi.
I have a question. Can I ask
Sure.
you?
Sure, please.
Hi. What is the educational criteria to join the PhD program? What is the educational criteria to join this program? I am a master's in mechanical engineering.
Okay.
Yeah.
So
I'm a master in.
Yeah, I mean, so as we do not have a hard. I'm sorry. Yeah, we do not have a hard requirement of doing and having a bachelor's, that students should have a bachelor's in computer science or related field. So you may still apply. There's nothing barring you from applying to our PhD and master's programs. However, we do look for some sort of assurance that you can actually do well in the CS program, right? So if you have other sort of certifications or any sort of things that you have done related to CS, that would help your case. But in generally speaking, so there is no such hard rule that you've done mechanical engineering, so you can't apply to masters in CS or PhD in CS.
Yeah. Now I am working as a research engineer. I would like to switch to computer science.
Sure.
I have a thorough knowledge in computer science. Am I eligible to join this program?
Yeah, as far as I can tell, maybe Rashri can comment more, but as far as I can tell, you're eligible to apply. Rashri, do you have any comments?
So we do have listed some prereqs on our website for non-CS majors to get admitted.
Oh, really? Okay. Okay.
there are a couple of prereq classes, and those are more important for master's admissions than PhD. For PhD, the research match is the most important factor. However, if a faculty advisor wants their candidates to be a TA when they arrive, they cannot be a TA if they don't have those prereqs completed. And so the faculty advisor will have to be ready to pick them up as RAs while these students complete classes like algorithms, systems, just because our undergrad classes are in systems, intro programming, and so our PhD students need to be equipped and skilled to do that. And so for that reason, the GradCom will not let non-majors without those prereqs be TAs for at least a couple semesters. Admissions to PhD, of course, as Gautam said, research match is the most important, and we do have many non-CS majors in our PhD program. If you want to get into a master's degree, definitely it's more competitive just because of the number of applications, and that's why those prereqs become really, really important filter. For PhDs, if you have those prereqs, it's better for you as well because you'll have to start tackling our graduate classes because you have to take 30 graduate level courses. And in order to be successful in those classes, a lot of students do go back and take those basic classes in order to kind of be successful in classes like machine learning or grad level algorithms even, and so that's just the experience, definitely. And so somebody's asking me, what about scholarships if we get a chance to be a TA or an RA? So if you are admitted to a PhD program, you are admitted with 5 years of full funding commitment. And this funding can be in the form of TA or an RA-ship. And that kind of includes your tuition for 9 to 18 credits, 91% of health insurance if you sign up for the student health plan. And then there's a stipend of approximately $2,500 per month during your academic year. That's for PhD admissions. And then there are fellowships that we also actually give during admissions. That's called university fellowships. It's about $5,000 for your first year in the program. For masters, unfortunately, we don't have any scholarships. Master's admissions, no commitment. Once you're here, you can actually connect with faculties, and if you click with a lab or a faculty wants to hire you as an RA, it's completely up to them and the research match. If you want to be a TA, you cannot be a TA during your first semester because you have to go through a training and an interview process. And then in the next semester, if we exhaust all our PhDs, then we still have TA slots available, then those go out to master's students. So I hope that answers your question, Daniel.
Hey, I have a question along those lines. So, right, you're saying it's about the research fit. Is that about what you're potentially interested in researching as a whole, or like when you're applying, you already need to know generally which lab you're going to go into, and if so, how does that really fit with this idea of coming in with more of an open mind and a curiosity
Spence,
to the room, right?
Sorry, Gautam. Spence, definitely it depends from faculty to faculty and lab to lab on how they review your applications. At times, faculties have certain projects already, grants in place, and they would be looking for students to actually work with them on those grants. So they'll be looking for that kind of skill set or that kind of research interest, at least, like you'll be at least inclined to. So your research statement within your statement of purpose is really important for PhD applications. When faculties are reading your application, that will be the first document they read, right? They'll read your resume, they'll read your statement of purpose to figure out if you're a match or not. And so we don't admit any PhD students without a faculty advisor is what I'm trying to say, I guess. But every group definitely, and they kind of recruit differently, there might be groups that are, most of them are okay. I mean, open-minded, not everyone has a publication or not everyone has kind of like a big research inclination when they get admitted, right? But at least faculty should be interested in your candidacy is what I'm trying to say. That's how the PhD recruitment goes. Does that make sense?
Yes, that does make sense. And then I guess a follow-on would be for Dr. Kaki, how is the PLV lab currently handling some of these? Do you have any advice on that?
the applications?
Correct.
Okay. So yeah, so I mean, so there is no hard and fast rule that some of us. So we basically have different grants that we have, that we're looking for students in to work on. So in that case, we actually see if any of your interests actually match with the projects that we already have. But in some cases, like the faculty like me, who just who recently joined, and I have a very generic grant instead of a specific grant directed towards a goal. I am looking more for someone students who are who can whose research interests match with my own, right? So we can start my own, so we can work on the things that I'm most interested in. So of course we'll have sometimes it's student comes with an interesting proposal for research in a domain that is closely related to what the professor has already been working on. So that would that would also be resulted that would also result in a successful application in some cases. But often it's the match between the students' research interests and our the requirements, the project requirements of professor and the interests of the professor. So that's what guides us during the recruitment.
Understood. Thank you very much.
Hey, Professor, it's Namrata again. So could you give us more information on what research is being done on distributed programming in the lab?
Sure. So it's going to be so I can give a long answer and a short answer. So the short answer is, so we have distributed, we are basically working on anything that has to do with correctness of a distributed system, right? So how can you make building correct, robust distributed systems easy, right? Just as easy as spinning up a sequential program. So if anything that is related to that goal is something that we are interested in. So that's the short answer, right? Long answer, we have lots of, in concrete terms, we have various projects. So for example, recently we have teamed up to write a proposal on synthesizing the distributed system implementations from their protocol specifications. Like you might have heard of TLA plus or plus Cal. So how do you synthesize an actual implementation from those specifications? So that's one project that we are actively interested in. The other one is has to deal with essentially the replicated data types that I mentioned, right? So you have not the systems, but the applications that are running top of the systems. So how do we ensure integrity of these applications, right? How do you write automated analysis, automated, the tools that can fit into developer workflow and ensure that if an application compiles or if an application is being deployed, it is in fact correct and it does not violate integrity limits. So that's another project that we have under our research umbrella. So yeah, these are like broadly what we are currently working on. But as I mentioned earlier, anything that is related to integrity of distributed system in terms of building distributed systems easier, we are interested in it.
Okay. Yeah, thanks, Professor. So I mean, right now I'm working a bit on Apache Beam, Flink, all those, distributed systems. Like I was just thinking whether this lab, like, are you recruiting any master student? I mean, is there any opening for master student in future? I'm coming in spring 2021. So yeah, I just wanted to know, is there any active, research being done so that I could contribute in some way?
So in terms of specific systems such as Apache Spark or things that you mentioned, I encourage you to talk to the systems group because they are the ones who usually do the work on the trenches of systems, right? So the systems that are currently deployed, how do you make them efficient? How do you make them, scale well, etc.? So those are the problems that systems group usually work on. So, but we are a little removed from the trenches of distributed systems. Like we are, we take a step back and ask, okay, so let's leave aside the current, state of things as such, and how do you basically do a fundamental difference in building distributed systems and in making really complex systems, right? So that's we don't deal with specific systems such as Apache Spark or something. but we deal with systems, distributed systems as a concept in general. So,
yeah, got it, Professor.
Okay.
Yeah.
I have a question regarding the application process. Do we need to select the group or, a certain professor that we would like to be our PhD advisor, or do we just submit our statement of purpose and CV indicating our areas of interest, and it just automatically gets passed to the right people?
So when you apply, Gautam, do you want me to take this?
No, yeah, please take it.
Yeah, so when you submit your application, there's some supplemental questions that say who's your preferred first faculty advisor, second, and third. So you can pick 3 advisors that you potentially would be interested, and those would be the first 3 people looking at your application, because the applications get distributed that way. And these faculties will read your application. If there's a match, definitely they'll be interested in you or your candidacy. If there isn't, and if they think somebody else needs to actually be reviewing that, they'll forward it to another faculty. So that's how it kind of runs the review process. And in that, for the CUPLV, maybe Gautam, you want to add more on how your group is planning on doing it. But in regular, when students fill out the application, they do have this extra question where they have to kind of select 2 potential advisors, and we run a query based on that.
Oh yeah, that's pretty much answers the question. That's how we do things in CUPLV as well.
Thank you.
Okay, any more questions? Okay, so that's all it is then. So Rajsha, you'll stop recording?
Yeah, sure, I think it should be fine.
Okay.
And kindly share the link with me, and I'll kind of post it in our site and share with the students.
Sure. Yeah.
Thank you so much, Gautam.
Thank you. Thanks, Rajshri, for organizing this. And thanks to everyone for joining. And as I mentioned, if you have more questions, please feel free to mail any of us.
Thank you, Professor.
Thank you.
Okay.